In this video, we are going to be learning about absolute zero. So temperature has no upper limit. In other words, things can get as hot as they possibly can. What happens when gases get really hot is they become plasma. When a gas is heated to many millions of degrees Celsius, the electrons actually separate from the nuclei of atoms, and that forms what we call a plasma. So there is no upper limit, but there is a lower limit. And we call that lower limit absolute zero. That is the temperature at which all motion of particles stops. It's 0 Kelvin, and on the Celsius scale, it's negative 273 degrees Celsius. So again, absolute zero is the temperature at which all motion of particles stops. In other words, at absolute zero, the particles have no kinetic energy. It is not possible to reach absolute zero. I'm assuming not even for Elsa, who is sad because, as frozen as she wants to get things, she cannot reach absolute zero. So actually, a little bit of a correction here. Maybe it's possible for Elsa to reach absolute zero. I don't think so, because it's not theoretically possible, but who knows how magic works. So if it's not possible to reach absolute zero, then how do we know absolute zero theoretically exists? We're going to work this out in a couple of steps. Gases expand when heated and contract when cooled. So let's say there's a gas inside this chamber. This is a piston that can move up and down. And the gas starts out with a volume of 1 meter cubed. Gases, specifically, they contract by 1 over 273 for each degree Celsius decreased. So if you decrease this 1 degree Celsius, then the volume will decrease by the fraction 1 over 273. So this picture here shows that if the temperature is decreased by 100 degrees Celsius, then the volume is decreased by this amount. So 100 over 273, so the volume is decreased by almost half. If you decrease the temperature by 273 degrees Celsius, then its volume and pressure would decrease to 0. So if the volume starts out as 1, and you subtract 1, then it decreases to 0. And obviously, a gas cannot have a volume of 0, so that's not possible. But this is how we know that absolute zero theoretically exists. So at this point, all of the kinetic energy of the particles is lost, so you can't get any colder. So again, we know that absolute zero theoretically exists because you can actually decrease the volume. You can actually decrease the volume of something, but it's not possible to decrease it all the way to 0. Here is a good time to talk about comparing temperature scales. So let's just focus on this picture for a moment. So the Kelvin and the Celsius scale are what we normally use in science. We almost never use Fahrenheit in science class. So water will boil at 373 Kelvin. It'll boil at 100 degrees Celsius, and it'll boil at 212 degrees Fahrenheit. Now, it's all the same temperature, it's just that it's different scales. So these numbers are all equal to each other. Now, water will freeze at 273 Kelvin, 0 degrees Celsius, and 32 degrees Fahrenheit. Absolute zero is 0 Kelvin, negative 273 degrees Celsius, and negative 460 degrees Fahrenheit. I will want you to memorize each of these points on each of the temperature scales. So absolute zero, you should know 0, negative 273, negative 460. Water freezes, you should know 273, 0, 32. For water boils, you should know 373, 100, and 212. Now, you may have noticed that I did not say degrees whenever I talked about Kelvin. That's because it's just standard in science not to use degrees with Kelvin. Another thing you may have noticed is that Celsius and Kelvin go up and down by the same amount. So to go from Celsius to Kelvin, you just add 273. So they go up and down by the same amount. What that means is that if you go up 100 on the Celsius scale, you'll also be going up by 100 on the Kelvin scale. Now, Fahrenheit and Celsius have completely different scales. For example, on the Fahrenheit scale, 32 to 212 is 180. But that's only 100 on the Celsius scale. So if you go up by 100 degrees on the Fahrenheit scale, you'll be going up by a lesser amount on the Celsius scale. So Celsius, if you want to know the formula, is 5/9 times the degrees in Fahrenheit minus 32. We're going to be working more with temperature conversions later on. And again, just a reminder, you should memorize these 3 points on the temperature scales.